So welcome to the third video on solving equations. This time we'll be seeing special cases. So the first one we'll see is called difference of squares. So there's a special pattern when you have a difference of squares. We won't go into proving why it is, but if you have a perfect square and you subtract another perfect square, that's why it's called difference. The difference is subtracting, and then a squared, b squared are the squares. Your two factors will be a plus b multiplied by a minus b. So we start by the first expression, 2x squared minus 18. Okay, I don't see any squares in there, but I do see a common factor, which would be number 2. So don't forget to always do your common factor if possible. So here we've got 2. First term divided by 2 is x squared. Second term divided by 2 is 9. And that equals 0. So since we have our perfect square here, we're left with 2x plus 3. So the square root of x squared is x. Square root of 9 is 3. So that's our first one. The second one is x minus 3 equals 0. Okay, so to solve our equation, we have to consider the first factor. It could be x plus 3 equals 0. And then the second factor, x minus 3 equals 0. And we'll go just straight to the answer, x equals plus or minus 3. That's if we solve for both of them. Now, the second case will be a bit longer because we have an x to the 4. It's not power of 2, but if you know your laws of exponents, you know that an x squared to the power of 2 gives us x4. So that means this is a perfect square. 16, that's 4 times 4. That's also a perfect square. And we have a minus, so it's a difference of squares again. So in this case, can't forget our equals 0 to be able to solve it. So we'll have x squared plus 4 multiplied by x squared minus 4 equals 0. Now, next thing we'll do, we'll notice that the x squared minus 4 is again a difference of squares. So there's a second step here. So we have x squared plus 4. That is not a difference of squares because it's a plus inside. And the second one becomes x plus 2, x minus 2, and still equals 0. Now, if we want to solve this, x squared plus 4 equals 0, x plus 2 equals 0, x minus 2 equals 0. It's completely factored. If we try to solve this, minus 2, plus 2, plus 2, this one will be minus 4. Okay, so to finish solving this, we'll do our sums over here. So here we have x squared equals minus 4. Here we have x equals minus 2. And finally x equals plus 2. Now here we have an interesting situation in that x squared equals minus 4 has no solution. Now I'll just put this null symbol. So the reason for that is you can't find the root of a negative number. Like when you multiply two numbers that are the same, you will always get a positive number. So there's no way to get a negative number. You know, it's not a real number. If you've taken some of the unreal or what's called imaginary numbers, there is a way to solve this, but there are no real answers to this. So we'll just leave like that, no real answers. And we're left with x equals plus or minus 2 as our solutions. Okay, next one, perfect squares. So perfect squares, like in this case, you have something of the form a plus b squared. A plus b squared. So imagine you have a square that has two sides that are the same length. So you'll notice we have 16, that's 4 squared, and 8, that's 4 plus 4, or 4 times 2, so it's double the amount. So that's how you recognize the perfect square. So for this one, what we would write is the x. We take the sign in front of the b coefficient, which is plus, and then you can write either half of 8 or square root of 16. So we'll work on square root of 16, which is 4, because that will always work for us. In some cases, when 8 is not 1, when the coefficient a is not 1, it doesn't work. So we have the answer is right there. So that means there's only one answer. We only have one factor. So x plus 4 equals 0. I should have continued with my equals 0 here. So we solve this, minus 4 each side, and we end up with x equals negative 4 is the single solution. Now in second case, it's a bit longer to figure out, but you'll notice you have a 9 and a 25. So as soon as you see two perfect squares, you should check to make sure if it's a perfect square or not. So 9, 25. So we have root of 9 equals 3. Root of 25 equals 5. So if I multiply both of these together, the product equals 15. So you'll notice if I double it, it becomes 30. So that's a little test you have to do. You take the root of a, the root of c, the two coefficients, you multiply them together, and if you double it and it gets you coefficient b, it is a perfect square. So erase my little test. What I will write is 1 bracket to the power of 2. We'll have a 3x. We take the sign from the middle, which is plus, and I take the root of 25, which is 5. So to solve this, it has to be equal 0. So we end up with 3x plus 5 equals 0. We start by canceling the 5 on the left by making it 0. 3x, nothing happens. 5 minus 5 is 0. We're left with minus 5 on the right. Then we divide by 3 on each side. Okay, I'll move this a bit. Should still be able to see the question. There we go. And we are left with x equals minus 5 over 3. And again, we get a single solution. If you were to look at this on a graph, okay, so if we were to look at this on a graph, at x equals minus 4, which is somewhere over here, we would have a single solution that looks like a parabola, just the vertex is touching the x-axis. So that would be our solution, x equals negative 4. Okay, and that's all for the special cases.